you've heard before something about continuous integration. We're going to use it. It's the thing to do. And maybe you're confused by that, or you're not sure what it is. You're going along because you're told to do that. That's what we do, right? We use these tools. But why do we use these tools? What's the basis for these tools? They help us out. They do some stuff for us. They make sure that stuff's not broken. Well, that's a little vague. Why do they do that for us? How are they helping us out? And so, something I've heard in the past 2 to 3 weeks is I've heard more than one person through different channels make reference to something called um, first premises. Like I want to explain this. I want to base this on first principles, or let's go back to the underlying philosophy and let's establish that first, and then grow from there. Let's talk from that point forward. So I want to share with you a problem that I ran into early on in my career. Okay. This is way back in 97 when I got hired. It's a different company from years ago. And um, essentially, I was not hired to write the software. I was hired to test other people's software. See, they didn't quite let me at the new stuff yet. It's more because I had come on late in the contract. And a lot of the people, not only were they more experienced and more seasoned, they had been on the contract for much longer, months, if not years. So they knew the business domain, they knew the stuff. And so when they hired me as a college new grad, the a role I could fill in was they needed more testing of their stuff. Now, there's a previous episode of the Pro Coder Show where I delved into talking about testing code, but one of the things that I also happened to do is I shared a cubicle with another junior developer, and his job was to go build the software for other people. Now, this is an ADA system, way back when, it's a government contracted system. And there was a certain point in time when that was sort of like, well, that was the point of ADA. It was designed by a committee. So to help with government contracting, so they could at least shore that up and not maybe burn up as much time on the acquisition process there, the procurement process, I should say. So this is a system that took 10 hours to build. Okay. And if there's one thing that they can't get back from pro developers on the team, it's if there's pro developers, if it takes them 10 hours to do a build job just to get going, to get off the ground. So today, somebody gives you an issue to go, you clone the repository maybe from GitHub, and you create a branch and you get going. And what does that take you? 5 minutes tops? This is a task that in this system, if they needed a clean branch, they came to us and we essentially gave them a copy. This is what you would call a snapshot checkout. So the thing is what we would do to help them out. See, this is a system that would take 10 hours to compile. You could say that's how big the code was. That's how slow the code was. That's how slow the machines were at that point in time. Um, it would do, like, if they edited code, it didn't take 10 hours every time they did a build job. It was smart enough to only build what had changed, but to build the entire system to run against took 10 hours. So essentially, they came to us. They came to my cube mate, I should say, when anytime they need to start a new task. This is the whole reason why you have feature-based branching. People talk about, don't use feature-based branching. It's don't have branches that are open for days, weeks, or months. This is the reason why they did feature-based branching, because if it took 10 hours to cut a new branch, then I'm not going to cut a new branch to edit one line of code, right? So they would come to him, and basically he would create a fork copy of the whatever the main branch was at, okay? And he would start a build job. Well, they had a second person, me, and I could basically learn what he was doing and double for him. So he could be on PTO, what have you, sick, and they had us both to cover that. So I started learning how to do that. So I would cut a copy of whatever the main branch was at, kick off a build job, and then I would go work on something else. Okay. And so I would be working in the background. And when it was done, arguably that would be the next day, because I wouldn't stay there for 10 hours for a whole day. The next day I could go to that developer and say, your branch is ready. So you can go grab it and start doing your thing. Okay. So I got very familiar with building branches. It was an almost daily task of me. I was building somebody's branch somewhere. And frankly, I got tired of doing that by hand. Okay. That was sort of like a bunch of manual commands I would get on my keyboard to issue that, to do all that stuff. Something else that we did periodically was we would have to make a release. Okay. Now, we didn't have all the tools that we have today. So to make a release, basically you had to move the version up, and the developers didn't directly manage that. To move something up basically meant, okay, this patch has to be okay. This patch has been coded and it's been tested by itself, but it needs to merge to the main branch. So once it's been merged to the main branch, you can then move the version pointer up to pick it up, and then another patch, and then another patch. And so maybe the fastest we ever did a release was maybe within 3 months. Like maybe there were 4 releases in a year. Not always that fast, but typically that took a lot of coordination between everybody because they're trying to figure out where to move the version, where to move the pointers to. And so that was something they would do every 3 months, at the fastest. Okay. And we would call that would be a run of integration, because essentially what you're doing is people have worked on their individual patches, but they haven't been able to see how their code works with everybody else stuff kind of mixed in a little bit. This is also the reason why you have decoupled components, so that the risk of changes in this component impacting changes in that component are reduced. Okay. So essentially, I'm deliberately not talking about the tools that we're using, because I don't even think that they exist anymore, the tools that we happen to use at the time. But we would, basically, we'd be at version 5, and then we need to move up to version 10. And what I'm talking about is for a given file. This file would be at version 5, and the file needed to move to version 10. We'll just take that concept and multiply it by, I don't know, 10,000 files. Every file had a different specific version on it. So they would have weekly meetings where they would review all the different patches that have been contributed and whether they were accepted. People would work on the stuff in their copies, and it's like whether or not this version would be accepted, whether you could fold it back into the main. Essentially, folding and merging meant moving the pointer up. At which point could you move the pointer up and basically pick up that change in the main branch? Okay. And I'd come up with this idea. I could go and ping the system in a sense, and be able to tell which change request documents had moved into a completed state. Okay. There was a way for me to go say, oh, okay, these 3 changes were completed by the person and had been signed off by the right project lead. So what I did was I sat there and said, um, what if I could just sit there and look at what's the latest version on everything? What if I went and the same thing I would do for the developers was create them a snapshot copy? What if I made my own snapshot copy and move that version up to those to pick up those 3 issues and just ran that? What would happen if I did that? So I sat down and I wrote some bash scripts to do that. Okay. I don't remember how long it took me because it's a long time ago, but I'm sure I spent days getting it working, and probably went back and made tweaks for many weeks thereafter. But it's basically, let me query the system. Let's see what's been merged. Let's now grab a snapshot of everything with those versions, and let's just run the build job. It's basically run the compiler. Okay. And if it breaks, well, we got a problem. We need to sort out. But that's not going to be hard to do because the previous version worked. This version worked, and then this version broke. So somewhere in here there's an issue. And we can probably trace it down if it's only 3 patched issues. Okay. We can probably get the right 3 people in a room to sort it out. So I wrote a script to do that, and I would run it during the daytime. I would launch this script. I would come in the morning and I would launch this script, and it would kick off a job. And then the next day I would come in and look at the results and see what happened. And then and then I would be like, okay, everything is green. It wasn't really green. It's just everything. There was no errors. Okay. That's all it was. No errors. And I would do that. I would go do that and run the script. And then I thought to myself, well, I'm here at 9 a.m. running this. What if I ran this at a minute past midnight? In other words, 9 hours earlier. I knew the job would take 10 hours. So typically, if I started it at 9 a.m., I wouldn't see the results till the next day. What if I set up a cron job and instead let the cron job kick it off at 1 past midnight? That way, the script can still look at what happened yesterday. What was the latest stuff as of yesterday to get merged in? What work had people completed then? And I could check it out. So I set up a cron job, and it would start kicking off, and I would have the results by 10 a.m. So this is something I started doing, and nobody told me to do this. Instead, it was more of I'm already kind of doing this analysis, these steps, these build jobs on a daily basis and checking things out. I said, what can I do that's going to help me in the process? And if I can have the answer by 10 a.m., I could go to the chief software engineer and say, hey, we've got this issue, and this is what happened. And can we talk to the relevant people? Well, when I started doing that, um, my manager loved it. We suddenly had a feedback loop telling us whether or not something there was a major breakage. And it's better to know that something's been broken within the last 24 hours than within the last 3 months. This is the reason why software, the cost of software development has been very complex, because it's like, well, something breaks. When did it break? Did it break last week or last month or last year? This is some of the analysis that people have been doing. And so they would bake in all these costs to say, well, you can write code, but we need to add extra cost for the integration phase. We need extra cost for the testing phase, and we need extra cost for the deliverable phase. And it's like, what if we could do like a miniature version of release? What all is involved to do a release? You need to make sure you're on the right version. You need to build everything. Now, today we also say you need to test everything, and then you need to bundle it up for release. Well, what if we could knock out the first two on a daily basis? Now, at that point in time, I didn't have any kind of like email, or I didn't have an email message get sent to me. Maybe I could have. I didn't know how to do that. And I certainly didn't have any, iPhone text alert to notify me about stuff, but I would just come in and look and see what the results were. And this is when I got my first taste of what would later come to be known as continuous integration. I was doing this on a daily basis just to know if there was something wrong. There's another thing that's used that kind of closely aligns with this, and it's called smoke tests. And it's a concept you run a barrage of tests, but it's not full, complete, extensive. Instead, it's a slim, basic set of test cases that if these break, something fundamental is broken somewhere, and you need to address it immediately. So it's supposed to be a quick, fast check to make sure the system isn't smoking while it goes down in flames. But the whole point of continuous integration is to have a process that is basically, this is where we started with. Let's build the software. Let's build the software. If it breaks in the build process, there's something fundamentally broken. We need to stop. And if we stop now and fix it, and if you think about doing that on a daily basis, the cost to fix it is shrunk way down because the scope has been minimized. The scope of what's probably broken is something that changed since the last job, since the last run of that has happened, which if you're doing it once a day means last 24 hours. So in the last 24 hours, what changed? So it's a tiny cost. And you fast forward, several days, maybe something else breaks. It's a tiny cost to track it down and fix it. It's a tiny cost to track it down and fix it. And if you add up all of those little costs in a given, like maybe you still release once a quarter, every 3 months. And if you add up the cost there, by the time you get to the quarterly point, you've kind of hammered out all the fundamental issues that arise with trying to integrate changes from different people, from different patches, from different stuff. Or at least you've hammered out a lot of it. Maybe not everything is checked out. We still need to have that, integration test run. We still need people to bang on the system, maybe run some of those smoke tests. But some of the fundamental stuff that maybe, you're working on your patch and another colleague is working on their patch, and what you can't see is you're both making some change to the algorithm in a fundamental way that competes with each other. And it works on your system, it works on their system, it works on your system. But when you mix them together, something falls apart. Maybe one of you made a slight tweak to the API and you couldn't account for that. And that's what having a continuous integration system at least helps you first catch. So if we're building the stuff every day, it's going to expose something like that. And that's kind of where we started with when it comes to continuous integration. And that's why, from a first principle perspective, the first thing you want to be able to do in this day and age with any continuous integration system is just build the software. Build it kind of the same way you would if you were doing it by hand. If you're running a Java Maven based project, just run the Maven command. Run the Maven clean compile, and put that into your continuous integration job, and run that every day. Okay. That's like a starting point for detecting what's something that's broken, because what it's going to put you on a path to is nobody can sneak in a major break, or, you can't, if you accidentally delete an entire file, something's going to break. Okay. And you're going to detect it. And then you're going to go back and glance at and it only gives you only have to look back at usually 24 hours to see what changed, to be like, okay, I fumble fingered that. Let's go fix that. Now, what continuous integration has done, it's then evolved a lot since then. And it's all the benefit of basically we're grabbing a piece of the entire life cycle of software development. Is it coding, building, packaging, testing, and release. And the idea is to pull it into right now. Let's do as much of that right now as possible. We started with building, just run the compiler on it. But in the past 20 years, the concept of test-driven development has really grown. Again, I'm not going to go into a lot about that. You can go catch that on previous episodes of the show here. But it is, well, what are we testing? How much testing can we do in this run? What's the cost of the testing? Does the testing take 3 hours? I mean, it used to be we had an entire, may still be the case. You may have an entire test team with procedures to go bang on the system in different ways, exercise different scenarios. People have moved a lot towards automated testing where you can capture these scenarios. But the point is, let's run what tests we can. Now, there's no guarantee in any of this that if something compiles, if it builds, if it packages, if all the tests run, there's absolutely no guarantee that there's not a problem in the system. But some of the biggest order problems that there are can be caught much quicker the more that we can do. Okay. So the more of the process we execute of what, the more pieces of a release process that we can execute right now, the better. And this is kind of the mindset to adopt when you're looking into continuous integration. You're like, why am I doing this? I'm doing this because I'm essentially trying to replicate an entire release. What's everything I would do end to end to release my system to my customers or users? What would I do? How much of it can I do from the continuous integration server? How much can I let the system do and give me back feedback so I can go mend stuff if it's broken? And it's this kind of stuff that has encouraged more scriptability. I remember working on a different system where the person next to me was building the Java front end web app, and their entire process was launch IDE, open this code base, click this button, click that button, run this build job, build a war file, build an ear file, all that kind of stuff through the IDE. And I mean, they even wrote up their processes so that the change management team or the quality assurance team, whoever was doing the build, they could carry out that process. I had never been a fan of, I'm going to instruct a human to go through a human-based system. I may use the IDE to write the code and develop the code, but I would rather have a bash script, run this one bash script, and then let it do everything. Let it go run through as much as possible.
If you're enjoying the show, give it a big thumbs up and share it with a friend right now.
So for me, I was a big fan of let's write a script. Let's script as much of it as possible and do that. And it was kind of like, I noticed anytime if I could do a job, if I could have the script do the job for me, fantastic, because that meant either somebody else could type the same command, and that's this much that I would need a human to do, or typically scripts can be connected to buttons. If there's some kind of dashboard, somebody can click on a button and it runs my script. Okay. Or that script can be rigged into a cron job so it's done at a scheduled time. Or this script can be hooked up to some pipeline process, which is now what we have with continuous integration solutions. And that's right. Really latched on to this identity that I felt like I was a script junkie. I was somebody that if I could write a script to get a job done, I would do it. And this is what drew me to things like Perl and Python and to a limited amount Bash. Bash is like the JavaScript of Linux. It's the one thing, it's everywhere. No matter what terminal you're in, you have access to Bash. And so you can do that. But when you start getting into conditionals and stuff, it can get complex really fast. So if possible, I like to delegate higher order scripts to something else. So sometimes it's just invoke a bash script and the bash script would invoke another script. And I've written scripts that would draft other scripts. But anyway, let's not go down that path. But I kind of saw myself as a script junkie. And at some point I learned about, automated testing. And I really got hooked into the go get the green arrow or green check mark, whatever, and you run a test case. I was what I like to call test bitten. I was lured into that, and I really like that to this day. I like testable stuff. So I call myself test bitten script junkie because if I could do something that way, I would. And so with the continuous integration server, the whole idea is, well, now I've got a machine sitting there idle, waiting for me to tell it what to do and waiting for me to tell it when to do it. So the first thing is like basically time. I say cron based. That's lingo for our industry to mean happens at a scheduled time. Okay, whether that's once a day. I've had scripts that run once an hour. I've written scripts that run every 10 minutes to monitor a system. Every 10 minutes, fire up a bash script. As long as the script doesn't take 10 minutes to run, it exceeds the window. A quick check, and if something's wrong, go run a maintenance script, something like that. So the idea that we can have pipelines that do a task for us and at a scheduled time frame. So like once a day. But as we got more sophisticated systems, source control systems, source code based systems, it didn't start with GitHub. There was other stuff before that, like the Atlassian tools were stuff that could give you hooks into this kind of stuff. They would really add a lot of metadata to your source code, but there are a lot of tools that could detect this. And some of the earliest ones was the almighty Jenkins, or what was called back in the day Hudson, because its original name was Hudson. I don't know if it was the first continuous integration engine necessarily, but it's certainly the one that everybody remembers from back in the day. And its whole penchant was it was named after a sort of a British inspired butler that was there to serve you. So a continuous integration server could sit there and either run at a scheduled time, like say once a day, and sometimes maybe you found out if you had too many jobs running at the same time, it could scatter the time automatically. This is the stuff that the server could figure out, like, well, here's a non-peak time. We're going to run it at this hour every day. And it can run what you need it to do, what you want it to do. But it could also be triggered when you made a commit, when you pushed something to the main branch. Because the idea is, once again, can we do the same checks that we've been doing in our run up to merging stuff? Why not run it on the main branch? That's what I was doing back in the day. And here's what this tool would do for you. You could say, I want you to monitor. And if there's a commit on the main branch, go ahead and run the whole thing. Go ahead and do that. So people quickly adopted that. And now it became an issue of, well, okay, we're running builds every day, we're running on the main branch. Are we running all the projects? Do we have enough computing resources? Are we allocated enough for the continuous integration server to do all this? Well, now it becomes a cost issue. You can sit there and go talk to management and say, well, we need to run 2 or 3 instances of this. They would, Hudson in the day, now Jenkins would essentially let you run a field of agents. You could run multiple agents and they could each be doing build jobs. And you have a master main controller that manages all that. But the point is, every time somebody would push a commit, go ahead and run it, check it out. And if it's broken, try this on for size. Why don't you email the person that made the commit? We don't even need to go through your QA or CM person to do this. Just notify the person directly and say, you broke the build. And it's like, well, the person that gets it probably has the most context, the most situational awareness of what happened. And they can be like, wow, I tweaked something in the last 10 minutes. It worked before then, but now it broke. It's probably something I did in the last 10 minutes, and they can get to working on it as long as there's agreement on the team of, if you break the build, you go fix it. And it's amazing to go look back on that and think, wow, what a novel idea. I broke the build. I should go fix it. And I'm probably the best person to fix it, not the person who manages the releases or not the person who's doing the release next week. Me, I broke it. I've got the most awareness. And now the cost, I talked about the cost has shrunk down here. Now the fact that you can detect it within like, oh, this happened within 10 minutes, the cost has become almost nothing. And this is what we get with continuous integration. And this is now we're starting to understand why do we call it continuous? Because that server is continuously building stuff as long as we're making changes. Anytime we make a change, you edit one line, we make a change, run all the stuff. Let's check it out. Let's build it. Let's run all the tests. And then we started doing something else that got added to the process. Let's build the artifacts and let's stage them somewhere. Now we could stage it on our own server. We could stage it on the continuous integration server. But by that time, we really had gotten enough awareness that it's like, okay, the continuous integration server is here to run everything, but it shouldn't be necessarily storing everything. It's an option to hold the snapshots, but for a commercial-based system that's closed source, we can publish it to a closed repository and the customers can access it if they want a snapshot. Or we can publish it out to somewhere like Maven Central if it's some open source toolkit. They'll publish it out there and somebody can consume it if they want to take a shot at it. If everything breaks, no publish. But if it passes, go ahead and publish it. It's not been fully tested. Okay, it's not been fully wrung out to verify that it's operational. But somebody can go pick it up if they understand, well, there's this amount of risk with it. There's a chance that it doesn't work and not everyone has checked it out. And so this is where we got the context of snapshots. And just think about now what that brings to us. And it's ironic because the way we used to build stuff where we didn't have all these processes, we're sort of like a self-completing loop in that we didn't have the resources to build everything, so we couldn't build everything. We didn't have the resources to run all our tests, so we didn't run all the tests. But by picking up a little piece of the process and automating it so that we could do it in a more continuous fashion, we started to recover that time factor. By running these automated tests, we recovered some of that time that was spent doing reintegration testing. The thing that we used to do where, okay, it's time for the quarterly release. We need 3 weeks to go do reintegration testing to hammer everything out. That task shrank more and more and more the more we adopted continuous integration. And this is what we call amortizing the cost. We're able to take a big cost and think of it as just chopping it up into little pieces and spreading it out into the cycle. Now you can sit there and debate whether or not, well, if I add all these up, does it equal this stack? It could add up to be more, it could add up to be less, but there's another factor in all this, and it's something called the time value of money. Okay. If you're able to take a dollar and go put it in a bank, it's going to be worth, at 100% interest, it would be worth $2 a year from now, and then $4 the year after that. There's something about the longer you get ahead of something, there's a cost, a growth cost, or in economics you call it a discount rate. So there's an element of if I chop up all this one big cost at the end into little parts, and this piece is really over here early in the cycle, the sooner I can get it, the more opportunity cost I can reclaim. Okay, so this may add up to be less than this, but if you add the discount factor, it could be more than that. But there's another factor to it, apart from the pure cost, the pure time factor. It's the more I can do it in these little pieces, the more confidence I can instill. Or another way to say it is, every time I spend this little bit of cost, the more I do this little bit of cost, the less risk I have. I can reduce the risk by this much every time. And as I go along the process and keep reducing the risk by little bits, by the time we get to release schedule, the amount of risk could have shrunk dramatically, but perhaps more than all this adds up to. Think about that. And so this is what the value of continuous integration is. We can be constantly building our stuff. And the whole idea is you don't have to get it right all at once. It doesn't have to be a perfect artifact or a perfect build job. The idea is to kind of start doing it. And as you do it, you find that it can do more and more of the process for you, and it can build confidence more and more. And it lets you then focus on, what do we not have down pat? What do we not have in a box tied up with a ribbon and ready to go? What parts of this do we still have to do manually? Can we go after that? Now that the CI server is doing this, can we focus on that and reduce the risk of it? Another thing I worked on at one point in time, and this is more I've talked about this before on the show with a testing system, was I inherited somebody else's app, and I would sit there and work on test cases and try to run the tests. And typically I could not get the automated tests to take less than 30 minutes. And 30 minutes today sounds like, I don't know, egregious for running a test suite. But there were times it would get up to an hour, maybe an hour and a half to run all the test cases. But if they broke, I knew I had broken something. And so that was sort of my wake up call to the value of automated testing. But part of what that did is because I introduced that kind of feedback loop of operating that way, it helped me move forward on the system, because some of the stuff I'm like, okay, this operation, it takes this long just because that's how long it takes to talk to the database. That's how long all these operations add up to. Some of the stuff there was unnecessary overhead that I could trim out. There were abstractions that had been put in that we didn't need. And I could start to remove them because I had some amount of confidence. Some of the risk of making changes had been eliminated. And so I could go after it. Now, this was not a system that was so directly hooked up to a continuous integration server, okay? But basically, we're talking about the underlying premise of, can I run everything and get the feedback so I can fix stuff, so I can improve the process? And this is one of the things that I'm now working on in my new position at Cockroach Labs. So the team that I'm on, we're training customers. We have customers, they're beating the door down on saying, we need training on this product, on this, on your ACID compliant cloud scale database. We need training for it. Get here as fast as you can. And we're feverishly working to put together rock solid content. And one of the things that I've seen an evolution from let me go back to Hudson, a continuous integration solution. The way Hudson started, there's a user interface. You go in there, you configure a given project, you set all its settings on a given display, on a thing. And I was never a big fan of that approach. And I've seen several other continuous integration servers with that approach, because let's be truthful here, they're probably riffing off the idea that Hudson had put forth. They thought, well, we could do better than that. We have a different spin on things, but they're building the same user interface. But at a certain point, people realized, you have this continuous integration job, you have all these steps, you have all the scripts. The scripts could be checked into source control. The operations that the configuration settings could be checked in as some YAML file or JSON file. Why can't the job itself be checked into source control? And some people said, why not do that? And so there's been this migration away from a user interface based continuous integration system to a file based. So all you do is you go to the continuous integration system and say, build that project. All the settings are in the project. And so now I can make updates to a continuous integration pipeline by just editing a file. It's all pulled under source control. If I back up and go check out a previous tag, what it needs to run is there. So I could actually ask the continuous integration server, run that version, and it's going to pull up its relevant settings, because all that has been put to source control. If you're new to being a pro coder, you may not be aware of the value of version control, being able to put as many things as possible under source control. Now, I don't know if they actually, or how much they teach source control in this day and age at the universities or the boot camps, or if they can fit that in or not. But that was one of the biggest discoveries when I shifted from writing code in my spare time as a high school kid to becoming a pro coder, was everything goes under source control. It's safety net. It lets you actually capture the state of the whole system as much as possible there. And that's a benefit. That's a massive benefit. And so being able to take a continuous integration job and pull it under that umbrella is fantastic. So when I got to the team that I'm on, we're trying to build slideshows. We're building decks with educational material on it. We're not using Keynote and we're not using PowerPoint and we're not using Google Slides. That's the other biggie. We use that for other stuff, but not for this training material. Throat's dry today, people. So, by the way, if this is catching your fancy, if you've used continuous integration stuff, put it in the comments. Go comment what systems you've used, and you can tell us whether you love them or hate them. Take a check here. B. Eli's got a comment. That's where the developer excuse comes in. It's break time. The pipeline's running. What are the tools or the approach that help avoid these long running pipelines and increase productivity? That's a great question, B. Eli. If you've seen the cartoon that says, why are you two in the hallway having sword fights, whatever? The answer is code compiling, but I've seen it updated as pipeline running. Part of it is you have to, I guess there's no deals in software. There's no shortcuts. You have to go look at the job and first of all, where's it spending most of its time? What's it up to? And that may be a biggie right there. Is where is it even spending all the time? It's probably in this day and age, it's probably not the compiler running. So what is it doing? I know that the Spring Boot team had, at one point in time, they were based on Maven, but they had to go to Gradle. Spring Boot had introduced this feature where you could do, you could have what's basically a little, you could run like a full-on integration test where it would spin up an embedded copy of Apache Tomcat, web controllers and everything. You run your integration test, can actually see that, and it could have a random port. You run your test, you ping the system, you get back the results, and then it all shuts down. And people would send in, integration issues. There was some issue like auto configuration something was wrong with auto configuration. So they'd put inside a little tiny Spring Boot app captured in a Java class in the test suite, and they started to accumulate dozens, hundreds, I don't know, maybe thousands. And they could get Maven to go run all that code, and it was like you're running 1,000 little miniature Spring Boot applications to replicate this. Believe me, when they built Maven initially, they did not see that one coming, and they realized some of the paradigms of how Maven operated. It was just not very time efficient. The build would take, I don't know, 30, 45 minutes. Maybe if I talk to one of the developers, they can give me a more accurate count on that. But they had to go to Gradle because that was a scenario where they needed better control over what happened. Maven has some amount of control, and in this area, clearly not enough. So they went to Gradle to get a better control over what was going to run and when it would run from a build perspective. And so that's a scenario where, yes, I do support that. I'm a big fan of Maven. I prefer Maven's declarative nature. I don't want a programming language in my build tool because then it's always seems to be breaking. But in this scenario where you really need this much control in the build process to run that kind of complex test suite, then yeah, that makes sense. So, in this one, B. Eli, you're gonna have to go look and see where's all the time going. And it may take you a lot of cycles to do this. This is one of the areas where if you're trying to debug continuous integration, many times the scenarios can only you can't run it locally. You have to run it through the continuous integration server. It kind of leads me to an area that I worked on. There was one shop that took the idea of continuous integration to the next level, and those people were Netflix. They actually came up with the idea of, we're going to have a pipeline process, but we need more than what any CI server is actually doing. We need a more complex one. We don't want to just check out the code. We don't want to commit to show up, and we're just going to build it, compile it, package it, test it, and drop it somewhere like Maven Central or wherever their commercial stuff is stored. We want it to roll out into production in a controlled fashion. We want it to go out to the East Coast, but not if it's primetime viewing hour. We're going to wait till after that. Then it's going to go out to the East Coast. And then after that, we're going to run 10% of the nodes on the new version. And if that passes, then we'll upgrade the other 90% to match it. And then we're going to update it on the West Coast. And we're going to have a similar tactic. And then we're going to a very complex rolling release, but they called it continuous deployment. It's continuous integration plus a pipeline based deployment, and it's called continuous deployment. And they built a microservice based tool to handle that called Spinnaker. And this is where you're taking what's, an infrastructure based system, this continuous integration that has to do with checking the system out, and you're merging it with production based stuff, how to actually roll it out to the field. And by the way, if that 10% canary test fails, roll it back. And I actually worked with them on that for a while because we were trying to hook up Cloud Foundry to work with it and Pivotal Web Services, which was the commercial flavor of that. And so this is where some of the only ways that I could see if something was running was I had to run it through Spinnaker. I'd actually have Spinnaker run a job. And sometimes you're like, click, run. You're sitting there telling, I need to run it. I need to look at the outputs through the CI tool. That didn't work. And it didn't tell me why. Let me try something else. Let me run it again. That didn't work. Let me try something else. It's a lot of trial and error. But I would uncover stuff. I would figure stuff out slowly but surely. I would look for ways I can't see what's happening at this step. Let me put some more print messages in that script. Let me try to dump out the state of the system in the script. And this is sometimes what it means to be a pro coder. Not everything is building the glorious React front end or designing a wonderful API. Sometimes it's that gory, you're getting down into the weeds, into the depths of the plumbing, and you're getting your hands in there trying to figure it out. Something else that we did, that I was responsible for was on the Spring Data team. And I was there. I actually managed all the pipelines for the 15 some odd modules. I migrated them off of what was Bamboo at the time, which was a user interface based system. I migrated us through a few different platforms and ultimately ended up on Jenkins because Jenkins actually afforded me the most tools and finally had a file based approach. And one of the coolest features that I saw emerge is the technology of Docker over the past 10, 15 years. People would pick up and run with Docker. They would use it in production to run their stuff or to run middleware, whether it's like Redis or Apache Kafka or RabbitMQ, what have you. And there's all these debates on should you run production stuff on Docker or whatnot? Where's the liability for that? And I didn't run stuff in production in my capacity, but so I didn't have a big comment about that, but the place I saw it emerge was with Docker, I could bake the right containers to have the tools I need to do my continuous integration process. Now think about that. Do I need to go to the system administrator every time that there's a new version of Java and ask them to install it on the CI server? Because that's what I had to do with Bamboo. I had to go correspond with our sysadmin, who would be on a different time zone than me, to do that. Or if there was what about Maven? This is where I liked when the Maven wrapper emerged. It pulled Maven into our control in our source repository. So instead of going to a system administrator and asking them to install Maven 3.9.1, I could put it in our system. But I could basically bake containers that had all the tools that I needed. So let's see, I need Java 17, and we're talking specific versions here. So I can actually know what's in the container. I need Java 17. For some of the stuff I needed to do, I needed to talk to BinTray at JFrog. I needed the JQ command line utility. I'd find other tools that I needed, GPG to sign artifacts to go to Maven Central. And so I could relatively quickly bake a container And then I could look, another factor was, is this container way too big or something? Am I using Ubuntu Linux? If I used Alpine Linux and shrunk the container down, would that work better? Would that, would that make it work faster? That kind of stuff. But it, it grabbed another part of the setup and let me pull it under source control because I put the Docker file into the source project. So the pipeline that's running is pulled under my control. The container that it runs inside is pulled under my control with the Docker files. And if I had a multi-stage pipeline, I would test it against Java 8, Java 11, Java 17. I could have 3 different Docker files and 3 subfolders. The pipeline would build the containers for me, and the pipeline would then spin up the containers to run everything for me. And so now here I've migrated way far along. This has evolved very far from I'm just going to compile everything at night. And I'm going to compile the latest accepted version of everything. Now I can sit there, I'm going to check out this repository when a commits happen. I'm going to run it through 3 different containers on 3 different versions of Java. Let's make sure it's all good. Which, by the way, I would just first check it against Java 8. Does it work with Java 8? If it does work with Java 8, go on and try the other permutations. Now I can run it against Java 11, Java 17. Let's do Hibernate 5 versus 6, that kind of stuff, or 6.0 versus 6.1 versus 6.2. And in that sense, if something broke, I'd know about it. Or if a new snapshot version of Hibernate came out and broke stuff, well, we could at least report it to them and let them be aware of it to deal with it. And we could warn our own customers, hey, don't grab the latest version of Hibernate 6.2, it'll break you, that kind of stuff. Not to be sinister, but to instead, we know the state of the system. It's no longer, I have confidence in the system, or I know what the risk of the system is. I know the state of the system in these different configurations. Okay. Works with Java 8, works with Java 17, is stable on Hibernate 6.0, 6.1. There's some open gaps in Hibernate 6.2. So we can sit there and advise customers. You can upgrade to Hibernate 6.2, but there are some risks. So you may want to watch that. And now we have a more complete picture to go into a customer meeting to serve our users, to be able to bring them that kind of detailed information. And I mean, and this is what managers want to be able to do. They want to walk into customer meetings and give the customer, here's the full story. Here's the state of the situation so that the customers can make a choice on this kind of stuff. And that's what the point of continuous integration is. It's to let us grab that release process that used to be, every 3 months or 6 months or once a year, in which there's a lot of tension, to be honest, a lot of nervousness, because it's like, well, this is the time we're going to start integrating. Maybe we'll get it out by our planned date, but the schedule may slip. Maybe there's something we don't know lurking that's going to tack on 2 extra weeks. By instead taking the process and cutting it down to small pieces and pulling it in, everything, we can more continuously be doing an integration process. And it pushes on us. If I'm on a branch and I've been working on something for 2 weeks on the branch, I can rebase it against the latest version of main and run all my checks, run it, let the CI server test it out, and see if I made a major goof or there's something that changed fundamentally that collides with what I've been doing. I can get alerted to it pretty quickly and deal with it. And I don't need to wait till 9 months from now when I've lost all context, when it's all evaporated and it's not even in my notes. Instead, I can better do that and have a better handle on what's going on, a better state of being with this. And that's what it does. It introduces confidence, it reduces risk. And if we adopt the concepts into our own flow, then you can sit there, then it becomes a fun discussion on X as to whether or not, I don't know, do you support feature branches? I don't know. I'm not a fan. I think we should work on main. I do like feature branches. Since feature branches aren't what they were 20 years ago, I don't know. It's a fun discussion, but it's not the kind of harrowing experience that it once was. And I think that's something that's important for an industry, for us to move forward, to have a more controlled, predictable, agreeable outcome than what we used to have. And that's what frankly I get excited about working on continuous integration. I'm looking forward to working with my teammate who's who's built what they have now so far and look at, hey, what can I bring to the table to contribute to that? So how can we make this process more effective? And what can we do so that we can get the content to our customers perhaps sooner, more effectively, more confidently, and we can share with them, here's the risks, here's the gaps, here's the parts we don't know about yet. And they can tell us, hey, we're willing to pay you if you can go work on that part, or we want you to work on this part instead. It facilitates the conversation. And, less risk, more stability, and more confidence, I think, is what everybody can benefit from. I want to thank you for tuning in today's episode of the Pro Coder Show. Now, don't forget, you can catch it on audio at podcast.procoder.io. And if you haven't already yet, go grab your pre-order copy of 12 Rules for Pro Coders. It's what a friend of mine described as something they wish they had at the start of their career. That was a huge thank you. I appreciate that. Go to 12rules.io, the number 12rules.io, and grab your copy today.
This episode is over, but your code writing journey continues. Visit procoder.io to find links and resources to help you become a pro coder.